Hi children, now we come to another topic which is about the circuit analysis. But before that, I will just give you homework on something on magnetism. So this is the one. See, these are the magnetic lines of force, and this is a substance here. You have to tell me whether it is paramagnetic, ferromagnetic or diamagnetic depending on the lines. Okay, then when you take anything, you have also to explain why you take the one, what is your opinion about taking that. And the number two is there is something, some miscalculation that day on the primary tone of the transformer and the secondary. See, primary voltage by secondary voltage should be 240 volts by 12 volts, which is 20. Now, primary tones by secondary tones is 20. So now, let's say that the primary is 300 tones, so the secondary will be 300 by 20 and 15 tones. So you have some correction on that, minor correction on the number of tones. So it's very important. And this also, we have to remember, taking the efficiency cent per cent. There is no loss of voltage between the primary and the secondary. Now, we come to the main problem. It is IIT problem. I think it is one of the most beautiful circuit analysis. Here we have 6.5 volt. Here R is 2 ohms. And then 1 ohm, 2 ohms, 8 ohms, 2 ohms, 4 ohms, 6 ohms, 12 ohms, 4 ohms, and all this. You have to find the current through R2. Question 1, 1 ampere. Question 2, 2 ampere. Question 3, 3.5. Question 4, 2. You have to take. Then, looking at this, you will remember Kirchhoff's laws. Then you'll put I1, I2. Then you'll divide I3, I4. Then by that time, you'll be very nervous. But let me tell you, inspection of circuit analysis of the circuit of the problem is very important. 6.5 volt and all this inspection. You just inspect here. Don't lose hope. Because if you keep on going I1, then I2, then I3, I4, it will take you 1 hour. So be careful. And this IIT people, they are very nice. They won't give you difficult problem. It can be solved in, say, 90 seconds. So now here, see. Just look here, A, B, C. We have done meter bridge a few weeks, 7 days ago. See, this is a Wheatstone bridge. 1 by 2 is 2 by 4. So it is a balanced bridge. 1 by 2, 2 by 4, balanced bridge. Though there will be no current through 8 ohms. So now what you do, 8 ohms is out. See? See now. So now 1, 2, say 1 by 2 is 2 by 4, P by Q, R by S, so no need to. There is no current in the galvanometer. This is like infinity. You leave it. So now this is left. So 1 ohm, 2 ohm, 2 ohm, 4 ohm. See? 1, 2, 10. Now you have to remember now, parallel combination. 1 and 2 is 3, 2 and 4 is 6 ohm. Parallel combination will be what? 3 into 6. 4 plus 2 is 6. 3 into 6 by 9. So what will become to? And I will tell you, never use that 1 by R1 is equal to 1 by R equivalent, 1 by R1 plus 1 by R. You will get confused with LCM and remember, R1, R2 by R1 plus R2. So we get 2 ohms. So now we come here now, 2 ohms, 6 ohms, 10 ohms, 4 ohms and 12 ohms. Very lucky again. See, these people have made the circuit in such a way, you again get a Wheatstone bridge. 6 by 12, P by Q, R by S. So leave 10 ohms. 10 ohms is no use now. So you have now 6 and 12, it is 18, 2 and 4, it is 6. 10 ohm is infinite. 10 ohms no need, because if you put the galvanometer here, there will be no current, so you leave it. See, this is the beauty of Wheatstone bridge. So here, 2, 4, 6, 6 and 12, 18. So remember, what is the combination? 18 into 6. 18 into 6 by 18 plus 6. So it is 9 by 2. So finally, you come back to here. 6.5 volt, then 2 ohms. Where is that 2 ohms? This one, 2 ohms. Then the final one you get, after all doing this thing, you get 9 by 2. So now, when you put this one, the current through 2 ohms will be 6.5 divided by 2 plus 9 by 2. So when you divide this, you will get 6.5 divided by 13 by 2. Now 13 by 2 is 6.5. So 6.5 by 6.5, it is 1 ampere. So when you come here, you tick which one? You take 1 ampere. So this one, it'll take some time because I have explained. But when you get this type of problem, you can do it, I can tell you, in 60 seconds, 65 seconds, you can do this. So remember, inspection, your eyes should be very sharp, and look for the Wheatstone bridge, because they will not give you very cruel analysis of 2, 3 minutes, 4 minutes. You'll be sweating. See, just remember the basic parallel combination, series combination, and Wheatstone bridge. So you will take 1 ampere. See, so beautiful, 6.5 by 6.5 ohms. It is 1 ampere. So I will end here. So next time I'll come to another topic as far as possible. So good night for the time being. We'll meet.